Ever pause to think about how your phone or laptop connects to the internet without a single cable? That invisible link enabling you to stream your favorite shows, chat with friends, and work from anywhere in your home, is all thanks to Wi-Fi. Today, we're pulling back the curtain on the science behind this everyday miracle, how Wi-Fi beams data through the air at incredible speeds, seamlessly connecting you to the digital world. Wi-Fi, short for wireless fidelity, isn't just a buzzword. It's a technology that leverages radio waves to transmit data between your device and the internet. Unlike the old days of tangled Ethernet cables, Wi-Fi uses electromagnetic waves. Think of them like specialized radio signals, similar to what brings your favorite NPR or iHeart radio station to your car, but finely tuned for internet data. When your device links up, it and your router are constantly communicating by sending and receiving these radio signals across specific frequency bands, primarily 2.4 GHz and 5 GHz. These are further divided into channels, ensuring your connection in a bustling apartment complex or a quiet suburb remains smooth, even with multiple devices vying for bandwidth. So, what happens when you click to watch that Netflix show or check ESPN? Your device first translates that request into binary code, the fundamental language of computers, a series of ones and zeros. Your device's Wi-Fi chip then converts this digital information into radio waves, which are then broadcast through the air. These waves travel to your Wi-Fi router, which acts as the crucial middleman. The router picks up these radio signals, converts them back into binary data, and then sends your request out to the internet via a wired connection. When the internet sends the requested data back, the whole process reverses, delivering the information wirelessly to your device almost instantly. It's a lightning-fast digital handshake happening right in your living room. The radio waves Wi-Fi uses are much higher frequency than standard radio broadcasts and are part of the vast electromagnetic spectrum. These waves zoom at the speed of light, capable of penetrating walls and furniture, though their strength can diminish with distance and obstacles. That's why your connection is usually strongest near your router, whether that's in a dorm room or a sprawling ranch house. Wi-Fi also employs a clever technique called modulation to embed digital data onto these radio waves efficiently. This allows numerous devices, from your smart thermostat to your gaming console, to share the same frequency channels without constantly bumping into each other, ensuring everyone gets their fair share of bandwidth. Keeping your data secure is paramount, especially with so much personal information flowing wirelessly. That's why Wi-Fi networks utilize sophisticated encryption protocols like WPA2 or WPA3. These essentially scramble your data, making it unreadable to anyone trying to snoop on your connection, protecting your privacy whether you're banking online or just browsing social media. Beyond security, your Wi-Fi router is a master traffic controller, managing the flow of data between all your devices to prevent bottlenecks and ensure a smooth, uninterrupted experience. So, the next time you effortlessly connect to Wi-Fi, take a moment to appreciate the incredible blend of science and engineering making it all possible, connecting you to the world, wirelessly, instantly, and invisibly. We've covered a lot today, from radio waves to encryption. What's your biggest Wi-Fi challenge at home? Do you struggle with dead zones, or are you curious about Wi-Fi? Let us know in the comments below. And if you find this explanation helpful, please hit like button, share this video with a friend who's always asking, why is my Wi-Fi so slow? For more adventurous scientific journey, just like, share your ideas and subscribe so you never miss any moments.